go. Hello and welcome to Precalculus. The topic for today is a little bit of the review, a little bit of the new stuff, which is slope of the linear line and rate of change. Maybe rates of change, whatever. So the linear line that you all know and love, y equals mx plus b, when written in this form is called slope intercept form, and this letter m is slope and the b is the y-intercept, also known as 0 comma b, which is the number you get to graph first on the y-axis, and then you count the slope. Now slope is understood as change, spell it out, change in y divided by change in x, in mathematics denoted as delta y over delta x, also known as y2 minus y1 over x2 minus x1. You ski down the slope. So you ski down the slope, at least you do until you break your hip or something. And what you have here, let's get one of these guys right there. There we go. There's the one arms, these sticks that they have, a head, a hat, hard hat, and the scarf, obviously. There we go. Perfect. So, gotta get some nose right there. All right. So the steepness of this slope is determined by calculating how far you get to go and how much your height gets to change. So this is what is known as delta y, which is the difference in height. So this is the change in height. If you're going to call this y1 level, and it's going this way, y1 level, and this is your y2 level, then the difference in there is going to be your delta y, which is the amount you went down. And you also go forward, right? Because you're not skiing vertically down, right? Down the mountain, because if you did that, it would always just be a little splash at the end. You go down the slope on an angle, which means that you're not just going down, you're also going forward, right, in the horizontal direction, and then horizontal and the vertical directions are combined to get this kind of sloped direction, right? So this is going to be your change in x, which is x2 minus x1, and then you can call this your x2 and this is your x1. So now when you combine these coordinates, right, and you get off this skiing horse, what you get is you get 2 points, x1, y1, and x2, y2. And you are able to define the slope as y2 minus y1, which is change in y, divided by x2 minus x1, which is change in x. And you are going to call that rise over run. Now, when you have a positive number, like m equals to, let's say, 2/3, then 2 up, 3 to the right. When you have negative values, negative 1 over 6, whatever, that's 1 down, 6 to the right. So you can see that denominator is always positive and denominator is always going to the right. It's the numerator that is positive or negative, and you get to go up for positive numbers and down for negative numbers. Now you might say, but Can I have negative in the denominator? Yeah, but you can also move it up. So if you have, 1 over negative 5, that's the same as negative 1 over 5, which is the same as negative 1 over 5. As long as you have one negative sign, this calculation is negative 0.2, no matter which way you look at it, right? If you divide 1 by negative 5, you're going to get negative 0.2. If you take a negative and then you divide 1 by 5, you're going to get negative 0.2. Or if you take negative 1 and divide by 5, you're going to get negative 0.2. It doesn't matter which way, where you assign your negative. As long as there is one negative in that fraction, the entire calculation is going to be a negative value. So because of that, right, we don't bother thinking about negative denominator and saying, oh, when it's negative, you go left. You actually do go left if denominator is negative, but using this witchcraft here, making sure that you never have a denominator negative, you can always say, oh, denominator is always positive and goes to the right, and if I see it negative, I can just fix it right quickly. So that's
So
all.
if you see a negative in the denominator, you can just move the negative to the numerator, and it's the same thing.
Perfect.
Okay.
Which is exactly what happens between, right, the first and the last thing, going through this kind of middle stage. All right. So now that that's behind us, the review about the slope and things, why do we want to talk about the algebra slope concept in pre-calculus? Because this concept can grow into something that we can actually use in conjunction with functions. And that is average rate of change. Now, before I jump into that, let me just talk a little bit about this idea of average. Um, you might know basic average, where you add all the numbers and divide by how many you have, right? That's the basic average. And most of the people, when you say average, they would think of that average. Um, there is also weighted average, which is what we use in our calculation of your grades, calculation of your GPA. It's all weighted average. It's not magic, right, on how, because we didn't use the basic average and now it's magic on how the GPA is calculated. It's actually very simple. The the basic average, and I'll call it basic average, is um, let's say all three exams weighted equally. So your average on three tests is your first exam 87, your second exam 62, your third exam 91, and now we just want to um, figure out what the average is. This is when all exams are weighted the same. That's a basic average. So now you add all of these numbers. So what do I got here? 240, I hope. And the average is, I just put these numbers, whatever, and it worked out to be 80. 7 plus 2 is 9, plus 1 is 10. That makes 100. And then 14, 240. Yeah, 80. Okay. So this is all three exams weighted equally, right? And the average is 80. But we can also have the weighted average. And this is where your first exam is weighted, let's say, we can do the increasing thing. So first exam is 20%, second exam is 30%, and the third exam is 50% of the grade, right? Well, in this case, your average is computed differently. You are going to compute the first grade times 0.2 plus your second grade times 0.3, because that's 30%, right? 30%. is 30 over 100, which as a decimal is 0.30, which is 0.3. So 30% is 0.3. And finally, we have the last exam, 91 times 0.5. So when you now do this calculation, you are going to get a different value. It's no longer going to be 80. I mean, it might end up being 80, but most likely it won't. So we have 87 times 0.2 plus 62 times 0.3 plus 91 times 0.5, 81.5. So now your average is 81.5. Now this is the average that is actually used for your grades. Like if you look at your syllabus now, you see that your exams progressively uh, have more weight. So all you need to do is to use those percentages next to the grades you have, and you can compute your grade, which is the reason why I ignore your emails when you say, oh, what's my grade? Just go and multiply two numbers, right? And the grades are available for you to see them, right, in Canvas under grades. So why are you bothering me? You can multiply and add numbers the same way I can. So if you're interested in your grade, you go and look at it, right? So basic average is when all are weighted equally, and then you just add whatever you have and you divide by how many you have. That's also known as mean. It's known as average, and so on. Now, the weighted average is the one when you have the weights assigned, which are these percentages, because some things are more important than others. So your final exam is 30-40% of your grade. Your homework is 10, which means final exam is more important, 3 times more important than homework, whatever. So these are the ideas for the weighted average. Now we want to learn about the average rate of change, which is another type of average, which is a step higher than your slope, and the slope is this basic average. So your slope m was y2 minus y1 over x2 minus x1. That's your algebra slope. Now in pre-calculus, we learned that y is equal to f of x. Right? We defined function as y equal f of x. So we can compute these y's as we plug in numbers into x. Okay, that means that y2 must be f of x2, because the y2 value, the y value, is going to be produced by plugging in x2 into the function. And y1 value will be produced by plugging in x1. Oh, well, now I can just plug these into the formula. And we get what we call average rate of change formula, which is f of x2 minus f of x1 divided by x2 minus x1. So this is your formula now. Technically, this is your slope on steroids, okay? You still have your y2 minus y1. It's just a fancy thing that you can write so no one ever talks to you again, right? Technically, you still have y2 minus y1 over x2 minus x1, except now you don't need to have those y's, because you can have a function and you can compute the change inside the function. Now, what do I mean by that? Well, remember how function is the series of those points that you can graph, right? You can graph any function. So we had that example for square root of x, where we calculated values and then drew a graph. So our graph was 1, 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. There we go. That's it. Perfect. So this is your square root of x graph, and you also have the function root x. What is the average rate of change between 4 and 9? Now, we are going to do the word problem to make sense of this, but this is just, basic example with numbers. Aha. What is the average rate of change between 4 and 9? So what are the things I have? Well, I just got that x1 is 4. I got that x2 is 9. And I also have that f of x is root x. Oh, so I can compute this. Average rate of change is equal to f of x2 minus f of x1 over x2 minus x1. All right, time to plug all of this in. So this is f of 9 minus f of 4 divided by 9 minus 4. Oh, I know how to compute all of this. F of 9, well, my function is root x, so f of 9 must be root 9 minus root 4 divided by 5. Root of 9 is 3. Root of 4 is 2. And what I get is 1/5. So the average rate of change between 4 and 9 is 1/5. Now, what does that mean? Guys, that's the slope of the line that connects those 2 points. So 1/5 is the slope of the line connecting 4, 2 and 9, 3. You can also use basic algebra. 3 minus 2 is 1 and 9 minus 4 is 5. So that makes sense, but in the word problems where you deal with velocities and things like that, you can't use that cheap shortcut. So all I did is just a lot of plug in. I know this because I learned that. That's the part of me learning the subject matter. I also was able to learn it because this is technically the slope formula, except instead of writing y2 minus y1, I have f of x2 minus f of x1. So there's that. And we calculated that the average rate of change is this. Awesome. So for the word problem or applied problem in respect to all of this stuff, we can say compute average velocity given position function s of t equals now 4t squared minus 3, whatever, on the interval, which is a time interval of let's go 1 to 3. It doesn't matter. Okay, now it sounds threatening, but you say, okay, instead of using x's and y's, now I'm using t and s. So what used to be f of x now is s of t, and what used to be an x now is t. So t is my, in quotation marks, main variable, which is what we call independent variable, and these interval 1 to 3 are actually my t1 and t2. Oh, okay, that's not that bad. t1 is 1, t2 is 3, so my average velocity is going to be s of t2, which is replacing your f of x2, minus s of t1 divided by t2 minus t1. The calculation is exactly the same as the previous problem. You're just now dealing with applied problem, which forces their own notation. S for distance, v for velocity, a for acceleration, right? You have angular velocities and all these things in physics. Guys, it's all the same.
Is velocity the same as rate of change?
Yes, because well, I'll explain that in about a minute. So now I know that I have to do s of 3 minus s of 1 minus 3 minus 1. Now, see, your position function s, right? Change in position, displacement, distance, all of these things. They're all given in feet or in miles or whatever. So let's say given in feet. And I have 2 seconds of travel time. From 1 second to 3 seconds, that's 2 seconds travel time. That second. Look what I get. I get feet per second. That's velocity. That's the units for it. If you want, I can change to miles and hours. Miles into hours. So you get your miles per hour. It's a velocity. And you can keep going with this. So your average velocity, usually you put this line on top to show its average, is going to be, okay, so what's my function? It's 4t squared minus 3. Okay, 4, my t is 3, squared minus 3, minus 4, this one now is 1, okay, divided by 2, because 3 minus 1 is 2. I'm in the units now. So as you can see, I used the function. Function was 4t squared minus 3. So now I use that one, but I plugged in the numbers that I am supposed to plug in. And I just need to compute this, and we're done. So 3 squared is 9. 9 times 4 is 36. Minus 3. Minus 4. And then plus 3, because the minus applied to this minus gives you a plus. And that all divided by 2. 3 and 3 will cancel. 36 minus 4 is 32. Half of 32 is 16. So the average velocity is 16 miles per hour, feet per second, meter per second, whatever the units are for the problem. But the average velocity, now that is 16 miles per hour. This just means that you are just driving from point A to point B, right? let's say it's taking you 2 minutes, you're driving through a neighborhood that the top speed limit is 25, and there are a whole bunch of stop signs and slow down, slow kids at play, and all of that kind of stuff. So that's that would be your average 16 miles per hour trip. You have to understand that if for most of your trip you're driving, let's say 50 miles per hour, your average is still going to be less than that, because you start your driving at 0 miles per hour. Well, that's going to go into your average, and then by the time you accelerate to 50 miles per hour, your speed is always less than 50, so that all of those times go into your average. If there is a stop sign, red light, geese on a road, you are going to slow down or stop completely, and that's all going to go into your average. So if you say for the most of my trip I went 50 miles per hour, so my average is 50, no, you also have to stop eventually. You don't get to campus, let's say, or your destination by jumping out of the vehicle, moving at full speed, you know, and and then going, when leaving the car, rolling down the street, right? You actually go to the parking lot and you park and you stop. Going into the parking lot, you're going 10-15 miles per hour, and then you stop at 0 miles per hour. All of those times also get into your average. So the function tends to smooth all of those um, stop and go situations. And then when you do this kind of average, it gives you the average across all of the values, right? In between the two given points, in this case, 1 and 3. So hopefully this made sense. And that's it. There is nothing else. I hope you're not disappointed. Our goal was to learn average rate of change. And then we reviewed slope before. I told you this is going to be a very short lecture, not even 30 minutes. And yeah, that's it for the day. I'm going to stay around for questions if you have any questions. Other than that, I'll see you all later.